Yes, it is. Yes, indeed.
No other damage.
No, no damage at all. Yeah, it was just an electrical storm. Um, knocked
Mm.
out a few transformers around the neighborhood, so they just had a lot of mess to clean up.
Yeah. Yeah, you live in a neighborhood where you have hurricanes from time to time?
Um, Very rarely, but yeah, it still does happen.
Okay. No, over here we are. It can be very windy, but in general it's quiet.
Mm-hmm.
Um, yeah. Okay. So
It's been a couple of
um,
weeks.
yeah, it's a long time ago, but it's good to have this hour back
Yes,
because
yes, indeed.
it was a crazy weekend last weekend. Uh, More on the personal and the family side.
Mm-hmm.
And next weekend is a crazy weekend.
Oh my.
and and then this week it took some preparation, and last week also.
Mm-hmm.
And on the work side, I don't know why, but I had more customers calling me today and yesterday
Mm.
than the whole of previous month,
Wow.
and 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 all with funny stuff. Uh, where I need Wireshark. Yeah, that
Oh
the tool that I
goodness.
need that I need every 2 years. I need to look up again how to use Wireshark. But
Yeah,
yeah,
yeah. That is a skill that yeah that fades away after after you say, okay, yeah, I figured it out. Put that back in the box.
well, I try to document it a little bit because otherwise every time I have to look it up again.
Mm-hmm.
And yeah, one customer, he couldn't connect to an FTP server to transfer data, just an old system, but
Mm.
for one or the other reason it stopped. And if I use another server from me, it does work,
Mm.
and it is on his production server, so they don't want to reboot it whenever. Another customer had on a laptop by the technicians all his software removed.
Uh-huh. Oh my
Yeah,
goodness.
it doesn't work anymore. The third one couldn't get connected, but finally it turned out to be just a firewall in a hotel where
Oh,
he was working from. So yeah, a
okay.
lot of things, but
So after
yeah.
after doing all this diagnostics, and you say, "Oh, yeah, move to a different hotel," yeah, is it like, "Oh, sorry, it was my fault all along," or like, yeah, "Oh, thanks."
No, but that one was quite fast because once I heard it was on the Wi-Fi of a hotel, I said, okay,
Mm,
take your 4G, your
yeah,
mobile, and it worked. So okay,
yeah. There we
but
go. Well,
the
good
server
evening,
issue
Caden.
is still open because the customer still has to come back.
Mm.
Okay,
So, Caden, how have you been?
Ethan, yeah.
Pretty well. Yeah.
Good to see you
So
again.
how was the situation last time? Your power went out?
Yes, yeah, we had an electrical storm the night before, and yeah, power was knocked out to several neighborhoods around me. So the electric company was busy repairing each one of them in turn. So
Oh,
it just took a little while to get everything back up for everybody.
okay.
Yeah, it was. I think it was 1 in the afternoon, and my local time it is currently 8 in the morning. So so yeah, it was yeah several hours before power was restored here. But
So,
yeah,
but
yeah.
still, the mobile phones were working, so the 4G network was on battery.
Uh, yeah, I guess yeah that makes
Yeah.
sense. Yeah, and the nearest tower is actually connected to a um, well, is there a tower? Yeah, I think there are repeaters connected to the water tower that's right next to my house. So if I was pinging off that one, then yeah, that had power. But I could have been pinging off something a little bit further away. Yeah, as I was driving to work, I saw power on in neighborhoods just across the street. We were able to get to the Starbucks, just a couple blocks down, which was definitely a requirement for my family to, we can't have our own caffeine here, but we can go pick some up.
Make the best out of it.
Yep.
Good. The loading and the saving of the records of the facts.
Yeah. How's that going?
The loading I still didn't do it, but the saving is finished and it works.
Excellent.
You want me to show it?
Yeah.
Or
Yeah, let's do
Caden,
it.
do you have something to start with?
Nothing for this time.
Okay, then let me show you. Which one is it? This one. I will just move it a little bit closer to me, that window. Is it visible this way?
Yes. Yes, it is.
So we had the SQL store. Where is it? This SQL store test, where we create the fact. Yeah. So what is it doing? It's just creating a new Jinaga instance with the new SQLite store that we had last time already, and then with that Jinaga instance we created a fact. So through the fact manager it will be saved. But that was already in place last time. So then if we go to where was it here? My SQLite store. So here I have the implementation of the save method on the iStore interface. If the graph is empty, so no facts in the graph, just return an empty immutable list of facts. And otherwise, I start with the immutable list of new facts that are the new facts that have been added, that are not stored yet, which is empty. And then the first portion we already had last time. To go over it very fast, it's just a for each loop. I open a single connection, and then I will from the fact type table, I will select the local fact type ID. It's always the same. I select, I insert, and I select again.
Yes.
The next thing is to get the fact ID. So the fact ID is based on that fact type ID that I had just now, plus the hash of that of the fact I want to save. One question here, because also in the next part of the story, we could just use the hash only and not the fact type ID.
Yeah.
It increases a little bit the chances for a collision.
Yeah.
Is it important or?
I think so, because there are. You could imagine in having different domains in which you've got fact types that represent root objects, and so they might have they might have no predecessors, and their only field is an ID, which is a GUID. And so if you had that same fact, actually in that that particular scenario, they would have to be the same actual GUID in order for them to produce the same hash. Yeah, it might also be an external ID, which has a higher chance of collision between two different systems. Um, but yeah, in general, um, the ID is not taken into account when computing the hash, and so therefore, I'm sorry, not the ID. The type is not taken into account when computing the hash, um, and so yeah, in general, I use the type and the hash to identify a fact. So yeah,
So
I think it's
leave
important
it
to
in.
use them both. Yeah.
Yeah. Okay. Um, so here we get that fact ID. If it does not exist, we will insert it and we do a new select.
Mm-hmm. Yeah. One last thing on that. It is important to have the index um, in the right order. So the hash is more selective. So it's important to have that as the first part of the index. And so that gets the database to do pretty much what you were just talking about. Is that it'll first look it up by hash, and then if there's a conflict, it'll move on to the next one. Um, but yeah, most of the time,
That's
just a hash is
uh,
enough.
that's why you always put the hash first and then the ID.
Yes,
I was
in the
not.
index declaration.
Yeah,
Yeah.
yeah. I was not aware that that had an influence. Um, that's a good one. Let me move this a little bit. And then for that fact, for each predecessor of the inserted or already existing fact, we have another for each loop. And so that's
Mm-hmm.
where we got where we ended last time. So for each of the predecessors, we will insert the role. Role is again the same system. We have to get the local role ID.
Mm-hmm.
So first we check whether the role is already available in the database. If it is not, we will insert it. And after we inserted it, we have to get that role ID to
Mm-hmm.
be sure, just in case of conflicts.
Yep.
So here we have our role ID. And then what is left is insert the edges and also fill up the ancestor table. To do that, we have to find out first what type of predecessor we are talking
Mm-hmm.
about. It could be just predecessor single, or it could be a predecessor multiple. Predecessor multiple was a predecessor which has in the same role multiple predecessors. Yeah.
Right. Yes.
For example, somebody's first name has been changed, but has been changed on two nodes simultaneously. So we have two possible first names.
Yes. Yes. Exactly.
In case of a predecessor single, first thing we get based on the reference of the predecessor, we get a fact ID of the predecessor.
Mm-hmm.
And then we will insert the edge and we will insert the ancestors. Yeah, I will come to the subroutines immediately. In case of predecessor multiple, then we have to cast this predecessor to predecessor multiple type,
Mm-hmm.
and we go through all these predecessors. Each time the same thing, we get the predecessor's fact ID, we insert edge and ancestor.
Yeah.
So if
Yeah.
we have a look,
One small note on C sharp. Now you can avoid the cast by declaring the variable inside of that case. So basically, you're using pattern matching.
yeah,
Um,
and how does
so actually, yeah, actually, you do have the variable declaration. So S and M are now variables of the correct type. So you could use s.reference rather than use the cast of predecessor single.
here var predecessor multiple ref as predecessor multiple?
In that case, M. So you can where you've got the parentheses predecessor multiple predecessor. So you're doing that cast. M already contains the correct cast.
I don't get it. I don't get it. So
Yeah. So the
okay, yeah, because here we have the predecessor multiple. So I don't need this cast anymore. Is that what you?
yes, if you replace that whole cast with just M, so M dot references,
Okay.
that will give you the right thing.
So
Yeah, so go ahead and get rid of predecessor as well, because it's basically copied predecessor into M.
yeah, like this then.
Yep.
And I can do the same thing here, just s dot here s dot reference like this.
Yes.
Okay, learning something new every day. So by getting this predecessor factor ID, I could just make this insert edge and insert ancestor very similar in construction in parameters. If we go to the insert edge, what do we have here? Here we don't need a local ID back. So I just do an insert or ignore based on the role ID, the successor fact ID, and the predecessor fact ID. And if we go the insert ancestor, same structure, we don't need a local ID. Here, what do? We insert the new fact plus the whole previous tree that was the ancestor tree of the predecessor. All together, we insert them.
Yes.
But that means that ancestor table will grow enormously.
Yes, it will.
Because every time the whole table will be added.
Yes.
Not the whole table, but
yeah, it is a pre-computed transitive closure. Yeah. Yeah. So that is a space-time trade-off. The time that you save is when it gets to load, and you say, okay, I want to load this one fact. So it has to figure out the transitive closure at that point in order to give you everything that makes up that fact. And if you've got it pre-computed like this, then it just looks up all of the ancestors. But if you don't, then it has to do this recursive query on load. Yep.
And there is no other way because that table will grow enormously. But you're using it in that training system.
Yes. Yeah, that was a change that I introduced a few months back, and it took some time for it to compute that ancestor table. So that was part of the migration. So yeah, I can look at the size of that particular ancestor table and get a feel for how much data is in there versus how much how big that table is. I haven't looked at the size of that table, so I don't have that number. But yeah, that would be an interesting number to take a look.
Because I'm wondering on a mobile phone whether we risk to run against the limit there. But
yeah,
okay.
that is true. And would a mobile phone need? That is a really good point. So for the mobile, we might actually decide that it makes more sense to take the opposite end of that trade-off. Because with the server, you're calling load, you're saying here's a whole bunch of of facts. I want to build a graph that contains all those facts and their predecessors. But for the mobile phone, you're not actually calling the load API. So when you run a query on the mobile phone, you're going to have as the result of that query, you're going to have to load some facts into memory. And yeah, that'd be interesting to see, to go ahead and measure it both ways.
Yeah. This we are not going to answer.
Mm-hmm.
The next one calling. Well, let's implement it in real application and see how it goes.
Mm-hmm.
So in this implementation, I didn't use any caching for the moment.
Mm-hmm.
So even the fact IDs are really looked up from the table. I think we will start that way and see how it goes, and we can build in caching as we go.
Yeah. Yeah, I like that approach. Yeah, we make sure that we get it correct in the cache miss case, and then that also lets us see, at the very least, intuitively, how much the caching is helping us. If not, actually put measurements into place.
Mm-hmm. But so that's the saving of a fact. So if we go to the SQLite store test, and for the moment I have no database. I deleted the database.
Mm-hmm.
If I well, we can walk through it. Let's debug. I think pointer is still there. So here he stops at a save. Let's go in it here. Of course, it's not empty. We have an empty list here, and then in that fact graph, we have two facts,
Mm-hmm.
the airline and the airline day. So we take the first one here. What am I doing here? Oh no, I'm
So it looks
further
like
than that already. Yeah. Okay, never mind. I should have put a breakpoint in. But anyway, if we go and look now to the database.
Yeah, which is the more exciting part of it. Yeah.
Yeah, let's show you that one. Oh, then I have to stop the screen sharing here. Stop streaming. And go to this one. So I just connected to it. Is that visible?
Yes, it is.
Yes.
Yeah. So I have my fact table. We go to the data.
Mm-hmm.
We see that we have two facts here. Yeah. So the fact type ID is different for both, which is normal.
Mm-hmm.
Different types. We have the hash. And here we see the field. So the first is an airline without predecessors.
Mm-hmm.
And the second one is airline date.
Yeah.
Date, and which has as a predecessor the airline, where you see also the hash included.
Very nice.
We go to the type. How does this thing work? Like this. So I have airline and airline day, so that's fine also. If you go to the roles, we have role airline. Yeah, so one single role. If we go to the edges, we have just one edge, which points from the successor to the predecessor.
Yep.
And if we look to the ancestors, Yeah, it's very small for the moment.
It won't
But
stay that
if
way.
we build up, if we build up the tree, I should add a few more levels, just to see that tree building.
Yeah.
Uh,
Yeah, because
but
right
it
now,
builds well.
right now we're
Yeah,
not exercising the that second clause of the union. So,
yeah.
yeah, that would be an interesting test to add.
Well, we could do that. Let's see if we go to the Tor test. So an airline day points back to an airline. That same airline day could point back to two different airlines. Am I correct?
Uh, no, that one is a predecessor single. Uh, yeah, if we have a flight that points back to airline day, which would then have a predecessor of airline, so that should give us fact ID 3 being the flight having two ancestors, 1 and 2, the airline and the airline day.
Yeah. Flight is wait, G dot fact
Yeah, and
and
you're sharing
fact.
the database again, so we
Oh,
can't see you typing.
stop streaming and
This is exciting stuff. This is testing on the fly.
yeah. So the flight, a new fact, and a flight. It had what as an? It points
Um,
to an airline day.
yes. Yeah, it should have airline day and flight number.
So it goes to airline day.
Well, you need first of all new flights because you're doing
Okay.
JDAT fact, so you need to have um, the object that you're creating. You're skipping
Wait,
one step and going to the parameters to the constructor.
yeah. Wait. No, this one was not here. But my.
Yeah,
Oh,
so where
okay.
you've got
Yeah, I
airline day,
see.
you should
Yeah,
say new flight. Yeah.
yeah. And then he comes. I haven't
Yeah.
been long enough. Too long. No. Wait. A new airline day. And what else does it need? A flight number. 555.
Yeah, the
Does it need other
555 is
things?
always right on time.
Adjust
Very few people will get
and
that joke.
Yeah.
555 right on time. Why is that?
The circuit for if you're building CMOS
Okay,
is the
yeah, it's
555.
a timer. It's
Yep.
a timer circuit. Yeah, yeah. I used it so much when I was as a little kid.
Oh yeah,
When I
that
was
was that was
14.
the most useful chip that you could buy. You didn't
Yeah.
even have to hook it up to to a crystal or anything like that. You could
Mm.
just you could use it in all sorts of other ways, make oscillators and yeah.
Is it still so popular these days?
Um, well, I know you can't just pop out to Radio Shack and get components anymore, but yeah, I think there's still some folks that are doing
Mm.
some of that low level electronics. Usually they're doing that in combination with like popping a microcontroller on there, and so here's a special purpose circuit, the microcontroller to do all the fun stuff.
I think I should still have a few of these 555s on in the attic in
Yeah.
a box somewhere. Uh, that's almost half a century ago that I
Mm-hmm.
used it. No, 40 years ago. Um, let's see. So that, because I don't have that model too much in my head. Um, so now if we would, can we have another predecessor of
Yeah. Yeah. So far, yeah,
like,
this is to test
then I
that
just
you've
have a
got.
next level.
Yeah.
But if I want to have a predecessor multiple,
Yes, I'm
in
trying to
this
think in
model,
this
it's
model.
no.
Yeah, I don't recall. You can control click on flight, and then let's go into the model declaration. We can see what we've got.
Yeah.
Yeah. So a nice little trick I like to use is control open square brackets S will select the current class in the Solution Explorer. There's also a
Wait,
button to do it, but I
wait.
can't remember where the button is.
I go on flight, control, and then?
We'll control click on flight to go back into that file.
Okay.
And then control open bracket.
Control open bracket.
And then S without the control.
No.
Oh.
Is it a square bracket or?
Yeah, it's the square bracket.
Oh, I took, but square bracket is.
Yeah, just
in
don't use
Europe
the shift.
we have funny keyboards in Europe.
Oh, okay. So it might be a different default key
It's called
binding.
AZERTY and it's a mess up. Yeah. The whole world is intelligent and uses QWERTY, but in Belgium and in France and in Germany they have funny things. So
Yeah.
what exactly would you like
Yeah.
to see? With
Yeah,
that one?
basically in Solution Explorer, I'm looking for all of the
Yeah.
related classes, and that's just
Wait.
a keystroke that I would use in order to get into that folder and see it all. So yep,
That is here
that's where
in
you'd
the
end up.
flight,
Yeah.
and then the flight cancellation.
Yeah. So flight cancellation is
Yeah.
still a single predecessor.
Then
It might
passenger
be
name.
passenger name. Yeah, that would have a multiple.
Yeah. And passenger goes to then I need to declare a user and then an airline.
Yeah, so I think it makes sense to do these as two separate tests. So the test that you've got right now can check the the ancestor going up 2 levels, and then you can write a separate test for saving a passenger name.
Let's run this one first. I just do run. He might fail here because I have my database. No, my database is open. It doesn't matter. Just when I want to delete my database, that's not working. So if I go to my Edge table, is it?
Yeah, and now we're seeing the code.
Wait.
So you'll need to switch your share.
Can I not just show you that screen? Screens. Which one is it? Not that one. Okay, so now you have the whole screen. That's gonna be easier. Yeah, but that screen is a bit big, I guess.
Yeah.
If I can just, no, I cannot make this bigger. It's not readable like this,
No,
I
I'm
guess.
afraid it's not. No.
Okay, let's. I like big screens, but for this it's not useful. Okay, go live. Now you see
there it is. Yeah.
So, do I have to refresh that one? Refresh. I don't know.
You should just be able to hit the blue refresh button on the grid view, and that should just refresh the data in the.
Here. You see, here I
Yeah.
have to. So that's correct, and then the big step, the ancestor.
Yeah. There we go. Yes.
So that's working.
So
that's
so
nice.
2 is pointing to 1, 3 is pointing to both 1 and 2. Yep.
Yeah. Okay, that's working. And then we could stop this one again. Really be able to share two applications at the same time.
That would be cool.
Which one was it? This one. Let's make it smaller again, or like this. So let's make another test then.
Yeah, and in fact, there should be. Well, yeah, it won't take too much longer to just do this. I was thinking there was a unit test that did the passenger name, but
it's multiple. Let's call it like that for the moment. Name, new store. That create. I can delete.
Yeah.
So here, that one I need. I will need. I don't know whether I need a flight.
Yeah, actually, you don't need the airline day. You just need the airline. Yeah, so a passenger is really a customer of an airline.
Yeah, let's see. Let's make the user first. Await j.fact. New user, and a user needs probably just a public key.
Yeah.
Whatever.
That's a good one.
So that's fine. And then var passenger is await j.fact. And then new passenger. And then I need my airline. Oh yeah, no, I need.
Right, and so yeah, you did the airline in as part of the airline day.
Airline is like this, and then where's my air?
Yes.
Let's put him in as well. Why is that?
It would be a new airline day, so you forgot the constructor call.
Okay,
so yeah, you're passing those parameters straight to j.fact. Yeah.
Airline day. Like this.
Yep.
But in fact, I don't need that one. I don't need that one.
Nope.
So my.
But we can save them for the next test, which would be for the passenger to book a flight on a with the airline.
My passenger, he needs an airline, so that's the airline, and he needs my user. And then
now we can do the passenger name. Yeah.
Yeah, passenger name is await j.fact new passenger name.
Yeah, we've got.
And that one has
that
passenger.
fact.
Sorry.
You've got JE.
Oh.
Yeah.
Passenger. Wait, what was he? He needs passenger, and he needs. Let's make it Michael.
There we go.
And he needs the prior is just nothing.
Yes, which unfortunately it can't infer that is an empty array of passenger name. You actually do have to do new passenger name bracket 0.
Passenger name.
I think that's the next rule that the language team is working on for type inference. It'll certainly help in this case. So yeah, put a 0 inside of the bracket so it knows to allocate an empty array. Yep.
Like this. Okay, and then you take a second passenger name. I make it. And then
Yeah.
like this. The-
Yeah. So, yeah, in order for us to have the those two predecessors, we can put those in. I believe if you put them in curly braces, it does the right thing. So let's try that first.
Should be curly braces.
I think so, because yeah, that's the JavaScript way of doing it. But I think in C# it's
I can have
and
no.
yeah, go ahead and put the word new in front of that. And I think it'll infer. Well, okay, yeah, new passenger name brace. And I knew that there was a way for it to infer that though. Yeah, so just open close square bracket after that, and then it'll after the passenger name, just put open close square bracket. Yeah, keep the curly braces though.
Yeah.
Yeah.
And then like this.
Yeah. Yeah. I know that there's a
Yeah.
shorter way to say that though. I've just forgotten what it is.
I will look it up.
Mhm.
So now we should have. Let's just delete the previous database. Then we. Where is my database is here. Yeah, that's not gonna happen if I don't disconnect the viewer. Say delete. Oh, he has a whole file. Delete the whole thing. So now save it first and then run the test. Oh, where are? Oh, yeah. I don't need this. Huh?
Ah, right.
Um, did he run? Test run finished. So let's see. I will show you back the viewer. So I connected. So if now we go to the facts. Yeah, we
Look at
have a
all those
lot of
facts.
facts here. 3 name facts, I guess.
Mm-hmm.
Yeah. And we have a user fact, we have an airline fact, we have an what is this? This is
That should be the passenger fact. Yes, yeah, so you've got the user, the airline, and then the passenger, and then you'll have 3 passenger names.
Yeah, and the 3 passenger names. Okay. If we go and have a look, I have all 4 types.
Mm-hmm.
Then we go to the edges. Here we see a lot of edges. Yeah, that role ID 3. What were the roles? So 3 is the passenger. Yeah, that's from the
Mm-hmm.
name to the passenger.
Yep.
So yeah,
Yeah.
that looks
And
right.
so yeah, role ID
Then
4 being the prior. That's got multiples. And so yeah, now
and here we have the ancestors. Yeah, 3, 4, 5, and then the 6.
Yep.
So we see it growing very fast.
Mm-hmm.
That seems to be working.
Yeah. Yes, indeed.
Good.
That's progress. Awesome.
Let's go back to that one. Okay.
Yeah. So I'll let you
So the
finish
next.
the next tests on your own. There is one more thing that that I want to share before we adjourn for the day.
Okay. I'm happy to listen to that.
Awesome. Cool. So let me do the wait a minute, the screen. There we are. Okay, so yeah, I have been working on making sure that yeah. So are you seeing my screen? Or okay, good. Yeah. All right. So yeah, what I'm confused about here is I'm seeing that it looks like the stream has paused. Let's see if I can get this to update. Okay. Yeah, for some reason the stream has paused on our faces, but we can at least go over this. So so this is the language of declaring a specification complete with projections, and the idea is that the query endpoint, which currently takes a string of steps, will now be a much richer query language. So to kind of remind you of the string of steps that we've got, if we take a look at the parser spec, we can see that that's the that query parser. Like this one here. This has got some examples where I'm saying, hey, I want to generate this equal for this sequence of steps. So starting from wherever you are, take a step in the successor direction using the role called predecessor. So whatever that successor declares as the name of this thing. So yeah, S dot means do a successor step. P dot means do a predecessor step. So follow the role parent in order to find this. And then F dot type means now that you're there, filter it just to that particular type. The F, by the way, doesn't stand for filter; it stands for field. And originally, this was supposed to be any field, but then so type was really just a convention. But it became such an important point of optimization that it's like, no, this is literally type. So then with this syntax, you could have the exists and not exists clause. So you would follow another part of the pipeline, and if it produced anything, then it would pass the E, or it would fail the N for not exists. So this is the query language that is currently in use in Jinaga.js, and it's very linear. In order to support a much richer set of branching logic, I need to have another language. So I'll just go right on down to the example. So this is a full example of the query language that will very soon be possible. So first of all, you declare your starting point. So in the linear pipeline language, you didn't declare your starting point. It's just wherever you happen to start, just start following those steps. But here, we say, okay, I know that the type is Jinaga.user, and then I've given that a label. And then inside of here, you have in this portion of the query, you have several different different paths that take you
Labels.
to another label. Yeah, exactly.
Yeah.
So I'll label the next one assignment. That's of type to do assignment. And then the square bracket is how you would have the different conditions for that label. So one of them is this path. So from assignment, we should be able to go up to user, that being a Jinaga.user, and I should find that that is the same thing as the parameter. So that's doing a join. So that's one condition. So follow that very short path to the assignment, and that should be true. And then the other condition is an existential condition. So rather than using n and e, now I'm just using e. So the not operator there to not exists. And now these brackets are the same as these brackets in that they contain a set of labels. So let's label something revoked. That's a to-do assignment revocation. And then let's set the condition on that the revoked assignment, which is a to-do assignment, is equal to this assignment. So we've got we've got nesting of these conditions in order to create existential conditions, and then by having multiple labels within these braces, we're defining tuples. So the result of this query is actually a set of tuples of user, assignment, task. So those three elements are part of that tuple. And then this is the projection. So now these braces mean something different. These braces are the projection declaration. So I've got a field in that projection called descriptions, and that field is, now we're back to the original use of the braces. This now defines a set of labels. So so that field descriptions is actually a set of tuples. So that set of tuples is everything that came before: user, assignment, task, and then description. So so now we're looking for the descriptions related to that task, where not exists a next description, where next prior is that description. So the descriptions that have not been superseded. So so this query language is a lot richer. You can have multiple branches. You can have the projections, and it solves a couple of really interesting problems just all at once. So this is the general purpose query language that I am now putting into Jinaga.js, and so we'll have Jinaga.net use this query language in order to call the server.
Okay.
I think that this is neat. It's like mathematical expressions.
Yeah. Yeah, exactly. So the descriptions of all those different pieces are up here in the document. So you've got your given, and that can be any list of facts. So the linear pipelines started with a single fact. This now can start with a tuple of facts, and then all of the subsequent tuples that satisfy the specification must match on everything that's in that given tuple. And so that's going to open up some power that isn't even expressible right now in the JavaScript specification language in the within the code, but is expressible in C# now, and that is to have multiple conditions, multiple starting points. Like, for example, I'm a user, And pardon me, my cat is eating my ankle. I'm a user, and I'm looking for things related to this particular company that I'm a part of. So both the user and the company come in, and then I'm looking at all my assignments within that company. So we've got the given, then a match is a label followed by some conditions. And then conditions are either path conditions, so you use the arrow to follow a predecessor. So so now you've got the starting point. You know what type the starting point is, and you know the role name here, and so that defines the predecessor according to the role according to the schema we just looked at. And so we'll be able to identify that specific role, and then that gives us a particular type, which then we can use to continue this. And so you've got those paths following predecessors on both sides. And so that, just by its very structure, means that these labels are going to be in the valleys. So you can't have a label that's further up the graph, because without having a label that's further down, because there's no way to address in the opposite direction. You can't address your successors directly. You have to have your successors address predecessors. So that gives you that that constraint, which is important for this proof to work. And then existential conditions, and then the next predicate for the next rule that has to be true for these queries is this connectedness rule. So so if you've got multiple, like if I put the user and the company up here, and then I've got a few things that relate to the user, a few things that relate to the company, but they don't relate to each other, then I'm basically defining some paths and some other paths, but I'm not connecting all the paths. So the query parser needs to check for that. So speaking of the query parser, I have something working here in npm run interactive. And what that does is that that runs the that runs the interactive endpoint within the application, and passes in this docs specification.txt, so this file right here. And then that runs the parser, and it tells you the output. So right now it has said, yep, that is a valid query. So the set of givens is user, Jinaga user. The set of matches is, let's define the unknown to be thing, and the conditions on that unknown to be a path condition, where I've got the roles that are on the left are the owner, the roles that are on the right are empty, no errors on that side. The label that's on the right is user. The label that's on the left is always the unknown. So that has to start with that label there. And those are my only conditions, and this one has no projections. So if I were to make a mistake, then it would throw an exception saying, this label has not been defined. Okay.
Ooh.
So fix that. And then I could also say, here's the company, my app.company. And now it throws an exception. The graph is not connected. So then if I say my app assignment, so now I've got two conditions for this assignment. It's going to be assignment. The worker is a Jinaga.user, and that's going to be equal to the user. and also the, we'll call it client. Actually, I'm sorry. Starting from the assignment, then the client is the my app.company. That's equal to company. And so now it says, okay, you've connected the graph. I'll show it to you. So we've got those two givens. We've got two matches. One of them is the unknown for the assignment, which has two conditions. One that's the client, the other one is the worker. So the next thing is to turn that into SQL. And the really cool things that this solves for us, this actually in its this computes the interest calculation. So if we go to all the way to chapter 12 in the book, talking about generated behaviors, the last algorithm that I talk about in there is computing interest. And so by sending this query to the server is able to infer all of the facts that you're interested in, all of the things that would change this the results of this query. So the server's not giving you back the results. The server's giving you back the evidence that you can then use to compute the results yourself. So if, for example, there is an existential here, then suppose that an assignment has been revoked. So that assignment and all of its tasks are no longer part of the results. So so you would expect if the server was giving you back results, it wouldn't tell you anything about that assignment. The problem is, if it didn't tell you about that assignment, it can't tell you that that assignment has been revoked. So so instead, what it has to do is follow the query down into the not exists. So the tuple that it returns to you is user, assignment, and revoked. So it returns you that set of tuples. And so now you know about all of the revoked assignments. That way, if you learned about an assignment previously, now you know that it's been revoked. And even if you haven't learned about it previously, you might hear about it from somebody else. And this prepares you for that for that time, so you already know ahead of time that it's been revoked. It stops at that point, so you don't get all of the tasks for that revoked assignment because you're not interested in those anymore. So it's just by its very structure able to compute interest, and so I'm pretty pleased about that, and reasoned through it. I haven't written a formal proof of it yet, but reasoning through it, it's like, yep, that solves that problem.
That's going to be a very powerful query language.
Yes, indeed. Yeah, and it's just understandable enough that people might actually be become comfortable at some point in writing this themselves. So even if you don't have a client-side runtime, maybe this would be understandable enough that people could write their own client-side runtime or just write queries directly against a server. But it's also really easy to parse and really easy to generate. So yeah, producing one of these queries from our JavaScript client or our .NET client will not be terribly difficult.
Okay. Actually, with this query language, somebody can use his own runtime on his own platform if he wants to.
Yes, indeed. Yep. Okay. So.
Yeah, we went again.
Ah.
Yeah. Discord was still throwing me out. I was just saying, so with this query language, anybody could write his own runtime client side to connect to the Jinaga server.
Yes. Yep.
Okay.
That is my hope. It's not quite
That's great.
as terse as it could be, but I'm willing to make that trade off to make it more readable.
All right. That is a nice perspective. So then we can get the powerful queries from .NET connected to Jinaga server.
Yes, indeed. So yeah, hopefully by this time next week, it'll be generating some SQL and actually running those queries against some real data, and we'll give it a try. And then I can show you the next powerful thing that this does. But so computing interest is one thing, but yeah, I'll save this one for next week.
Okay.
Yeah, we're gonna be curious.
All right. Well, thank you all for hanging out with me again.
Thank you, Michael, for guiding us through this. All this, it's complicated, but step by step we're getting there.
Yes, yeah, I'm really looking forward to everything just coming together, and then we can write some .NET code. We can run it against a server. It's going to have this more powerful, query language, so it'll be much more efficient and avoid edge cases, and it'll we're heading toward a really good place.
That we can just have a groundhog session of 1 hour to write an application.
Yeah, yeah, and then throw it all away. That's my favorite part about groundhog coding. Yeah.
Yeah. No, I will keep it. You do what you want on your side.
It's not groundhog coding if you keep it.
Yeah. Okay. Michael, thank you very much. Caden, see you next week.
See you next week.
Very
Okay.
good. Thanks, Caden. Thanks, Jan.
Bye-bye.
Bye.
Bye bye.